Okay, so for the open-ended part of your test, number 14, we have the inequality 3x is less than or equal to 15, or when x is over 2, it's greater than 3, and we're asked to express our solution in interval notation. So for the part on the left side of the word or, I'm going to divide by 3 and get that x is less than or equal to 5, or to solve for x here, since it's being divided by 2, I'm going to multiply by 2 on both sides of my inequality and get that x is greater than 6. So if x is less than or equal to 5 or x is greater than 6, to help me out with interval notation, I'm going to draw this on a number line. 5 would be a closed circle, and because x is less than or equal to 5, I'm going to shade to the left where those values would be smaller than 5. And if x is also greater than 6, I'm going to have an open circle at 6, and 6 is not a solution, but it does tell me that all values greater than it are. Okay, one more thing I want to add to my number line, since I know I'm doing interval notation, those arrows are pointing towards my positive and negative infinities. So now if I read the number line from left to right, it's going to help me write my interval notation. So from negative infinity to negative 5, positive 5, negative mind frame here, to positive 5 with a bracket, that represents the first part over here, this part of my graph. Or, instead of using the word, we're going to use the symbol, the U, and now if I want to represent this piece, it's going to go from 6 with a parenthesis, because it's an open circle, comma, infinity. And just something to remember, infinities always have parentheses. The only time you are going to use a bracket is when you're dealing with a closed circle like we were for positive 5. Okay, for question 15, we are asked to solve this multi-step inequality. So I'm just going to rewrite it for myself. First thing I'm going to try to do here is to do some distributing and some combining of like terms. So on the left side, I'm going to distribute this negative 5. So I'm going to have 2x minus 15x plus 20 is greater than, and on the left side here, I did have like terms of negative 7x and positive 5x. That's going to give me negative 2x, and then that positive 42. On the left-hand side here, I do have also some like terms. Positive 2 and negative 15 is going to give me negative 13x, plus 20 is greater than negative 2x plus 42. Okay, so now I need to get either my x's on one side and my constants on the other. Sorry, that 42 looks not like 42. I'm going to start by adding the 2x to both sides, and I'm going to end up with a negative 11x plus 20, which is greater than positive 42, and then I'm going to subtract the 20 to both sides, and I get negative 11x is greater than positive 22, which then if I divide by this negative 11, I'm dividing by a negative, so my inequality symbol will switch directions. 22 divided by negative 11 is going to give me negative 2. So x is a value less than negative 2. I solved for x. Now, even though I kind of drew down into this next part, this part is the second half of question 15. So I want to read through this. It asks me, if x is a number over the interval negative 5 to 1, state all integers that satisfy this given inequality, the one that we just solved, and then explain how we determine these values. Okay, so I need to focus here for a second. This is telling me where x is. So from negative 5 to 1, if I looked on a number line, negative 5 to 1, they're both closed circles, and that interval notation means that I'm going in between these numbers. And remember, I know they're closed circles because they had brackets, and I know it's in between because interval notation, if all there is a comma, then that's telling me it's everything in between those numbers. Just going to make this a little clearer because I ran out of room here. So negative 5 and everything in between. Okay, so x is less than negative 2 was my solution to the above inequality, but now I'm being told that x is specifically these integers. So let's think about the integers that would be between negative 5 and 1. We would have negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1. These would be all of the numbers that would really fit on this part of the number line. Okay, so I need to answer the question, which of these integers would satisfy the given inequality? So which of these numbers are less than -2? So 1 is not less than, 0 would not be less than -2, -1 would not be less than -2, -2, because there's no end equal to line, is also not less than -2. These numbers, -3, -4, and -5, are less than -2. Another way you could have visualized that would have been to draw another number line for yourself. -2, open circle, everything to the left would be a solution for that inequality that we solved above. And then think about where all of these numbers would be. -1 would be here, 0, +1, -3, -4, and -5. And notice the -5, the -4, and the -3 are the only numbers in the shaded area. They would be the only numbers that would represent the solution here. So we're asked to explain how we determine these values. So we could just simply say, again, it does say explain, so you have to indicate something in words. The integers -5, -4, -3 are the only numbers that are less than -2 from the interval -5 to 1. Not the only way you could write it, but basically just explaining how you got to your answer, -5, -4, -3. Okay, question 16 is giving us an and inequality to solve, so I'm just going to rewrite this for myself. Alright, so I'm going to start by solving for x on the left-hand side here, so I'm going to add 3 to both sides to get that -12 is greater than or equal to 2x. Divide by 2, I'm dividing by a positive into a negative, so I do not switch my sign. X is less than or equal to -6, and so I have to keep going now, come to this side of the inequality. 11 minus 2 is going to give me 9. 9 is less than or equal to 3x. Divide by 3, so 3 is less than or equal to x, or x is greater than or equal to 3, however you want to look at that. Now again, I always want to visualize my inequality solution, so I'm going to put a -6 and a +3 on my number line. They would both have closed circles. And if I'm greater than +3, I would be shading to the right. And if I'm less than or equal to -6, I'd be shading to the left. But I have to think about this for a second. This is solving an and inequality. So can I find an answer that is both less than -6, less than or equal to -6, and also greater than or equal to 3? No, there is not one number that can satisfy both of these inequalities. So when you solve an and it really looks like an or, it means that there is no solution. Okay, question 17 says that Chelsea has $46 to spend at the fair. She spends $20 on her admission and $15 on snacks. She wants to play a game that costs 65 cents. So write an inequality to determine and state the maximum number of times, x, that Chelsea can play the game. So since x is in my problem, I don't need a let statement, but if you wrote a let statement, we're letting x equal the number of times that Chelsea can play the game, which is stated for us here. Okay, so every time Chelsea plays a game, it's going to cost her 65 cents. So let's start by taking the 0.65 and multiplying it by x. Then it tells us that she spent $20 on admission and another $15 on snacks. And she only has $46 to spend, meaning she can spend less than or equal to 46. She cannot spend more than 46 because she would run out of money. Now we want to solve for x. So 0.65x plus 35 is less than or equal to 46. So I combine like terms. Now let's subtract our constant. We get 0.65x is less than or equal to 11. Divide by the 0.65. And you get a decimal that comes out to be 16.9230769 Again, that would continue to show you more digits in the calculator. So you could have written any amount of these digits, but you do want to indicate a dot, dot, dot if you don't include all of them. So now we need to think about this. 16.9, if I was not in a word problem and it asked me to solve to the nearest integer here, I would round up to 17. But I need to remember what x represents. It represents how many games she can play. If I round up to 17, I'm going to end up spending more than the $46. So she can only play a maximum of 16 games if she is going to spend $46 or less. And a way that you can do this is to type it into the calculator. So if I typed in the original inequality that we came up with, and I tried out both answers, if I wasn't sure, should it be 17 or should it be 16? Look here, when we plug in 17, we get $46.05. Well, that's 5 cents too many. She only has $46. If we plug in 16 for 16 rides, then it's going to cost her $45.40. So yes, she'll have a little money left over, but at least she can afford to play 16 games. Question 18 is asking us to solve this equation for x. So you can start out by distributing the 7 over 3. So 7 over 3x plus, now 7 over 3 times 9 over 28. You can type this into the calculator, and it's going to give you a simplified fraction of 3 over 4. Now this is equal to 20. Now I'm going to isolate x. I'm going to subtract 3 over 4. Again, you're going to be typing these into the calculator, so you don't have to come up with any kind of common denominator on your own. We expect you to type this in. 20 minus 3 over 4 is going to give me 77 over 4. Then I want to undo the fact that x is being multiplied by this fraction by multiplying it by its reciprocal. And I'm going to multiply by the reciprocal on either side. And if you type in 77 over 4 times 3 over 7, you either get the fraction 33 over 4, or you could write it as the decimal 8.25. Either form, again, of this answer would be acceptable, decimal or fraction. And the last question here, solve and graph the following inequality. Okay, so we have negative 3x plus 7 minus 5x is less than 15. I'm going to start by combining some like terms. So I have negative 8x plus 7 is less than 15. Subtract my 7. I get negative 8x is less than 8. Divide by a negative 8, which again, I'm dividing by a negative, so I have to remember to switch my inequality sign. 8 divided by negative 8 is negative 1. Again, I always like to visualize my inequality solutions on a number line. So here's negative 1 with an open circle because it is not included, but everything greater than negative 1 is in my solution set, so I'm going to shade that. Okay? It's asking me now to determine and state the smallest integer in the solution set. So some of us might be thinking that 1 is the smallest integer. However, negative 1, but negative 1 is not included because it is an open circle. So now I need to think about what would be the next integer. Well, after negative 1, the next integer would be 0, and they would continue to go up consecutively. However, we're looking for the smallest integer, so the smallest integer in the solution set would be 0. Until